Hello everyone and welcome to our mechanism sessional project. Firstly, let me introduce you to my group members. Myself being Aditi Sunil Patil and my other two teammates being Aayush Mitra and Aditya Kumar. From the tutorial 5, we have chosen the third problem statement of the dumper truck mechanism having a gravity driven rear opening which has to be manually unlocked when it dumps. So basically it is an idea to have a mechanized door that opens as the bin tilt as it is shown in the figure. Major objective of this problem statement is that we have to find the range of the angle between the door and ceiling during unloading. That angle should be maximized, and to establish an automatic internal lock system when the dumper is in still state. We also need to show the relation between the dumper tilt and the angle between the ceiling and door. Firstly, we've done the synthesis of the mechanism. The figure shown over here is a simplified kinematic diagram of the dumper truck mechanism, and it is basically a 4R kinematic linkage. As you can see in the figure, there are 4 links: L1, which is 8D, link AB, L2, link BC, link L, which is L3, and CD, which is L4. So this L1, L2, L3, L4 form the 4R kinematic linkage, and just note that BCG link over here is a singular link.
Hello everyone, myself Aayush Mitra, and now I'm going to explain the calculation part of our project. These are some dimensions of our basic schematic diagram. The min dimensions is given as CG equals 480 mm, C equals 225 mm. The maximum door opening angle, as you can see here, this alpha max is 75 degrees, and the distance between the hinges attached to the ground. These are A and E. These are the two hinges that are attached to the ground. The distance between them is 75 mm. Right. Now, this is our first dead center configuration, which is a central configuration, and due to which the alpha here becomes alpha max, and these points A, B, and C becomes collinear, making it a straight line. Right. From this, we can see that angle AEC is 90 minus alpha max. Right. AC is AB plus BC, which in turn equals to L2 plus L3. Here EC is L4 and AE is L1. Now, to get the value of AC, we use some triangular properties on this triangle ACE using these values, and we get AC as 264.5955 millimeter. Now, this is our second dead center configuration when alpha equals 0 and points C and D coincides. Right. As you can see here, ABH is a right angle triangle, right? And here AH equals L1 minus L3, BH equals L4, and AB equals L2. So from this right angle triangle Pythagoras theorem, we get this relationship, right? And using this relationship and the result we got earlier, uh, we can get the values of L2 and L3, which comes out to be 228.306 millimeter for L2 and 226.285 millimeter for L3. This is next diagram showing the schematic diagram showing the big configuration and the 4R mechanism. Right. Here the theta is the input angle, which as an input to get an output from our. Uh, Alpha is the door opening angle, as we saw before here, right? Beta is the angle between link 2 and the ground, right? And the theta 1 is the angle between link 3 and with respect to the ground, right? Now this whole mechanism is basically what makes the door open in this whole big dumper mechanism, the door opening mechanism, this BCD, right? Now we want to find some relationship between these angles, right? These angles, so that we can derive different outputs from our inputs. So here A equals sine 90 minus theta. We have like given sine 90 minus theta equals A. Similarly, B is this, and we get a relationship for beta equals 2 arc tan theta A plus under A square plus B square minus C square upon BC, and we put these values in, and from there we can get these values. C equals I1 by 2 and by into cos 90 minus theta plus I1 square plus L1 square plus L2 square plus L3 square minus L4 square 2 L1 L2, which we get from here. And now from these relationships and simple geometry in this diagram, we can also infer this that theta 1 equals L4 sin 90 minus theta minus L2 sin theta upon L1 plus L4 plus 90 minus theta minus L2 sin theta. Basically, this whole equation. And further inferring from this diagram, we can also say that alpha equals theta plus theta.
Thank you, Ayush. Now I, Aditya Kumar, will tell you about the sort of model we designed. This is the door and this is the bin, and these are two links that are connected to door and base. And this is an actuator that you can see. The door is linked with bin with 2 points, first and second. Now let us see all these parts separately to have a good look on it. Now you can clearly see the parts, the bin, the door, and the links present, also the actuator. Now let us see the motion of the roller and see how these links change position with respect to each other. So thank you so much. This was our project. Now in conclusion, what we did was we firstly used dimensional analysis to find the length of links, and we ordered our simulation in SolidWorks. But about this, we created our 3D model. So